In this session, I'm going to look out for the two key types of return which are used in the investment fund management space or to evaluate the performance of various securities. They are the money weighted as well as time weighted kind of returns. Right? Two different forms of computing the rate of return on the investment, especially when I have different time periods, right? These two things make a difference, especially when I make my investment over a multiple time period and the cash flows are different at different points in time. Cash flows at different time points. It's not a one time investment, right? There are some cash inflows and outflows occurring at different points in time, some new investment added, some existing investment pulled out, and the returns and the fund values are computed at different points in time. So once we have this kind of different time, different cash flows, as well as different time periods of investment, as long as we have different cash flows and different time periods of investment, whatever the returns we are computing, we can classify them as a money weighted versus a time weighted kind of a return, right? So the key difference that exists between them, as far as the money weighted return is concerned, right? Money weighted rate of return, as far as this money weighted rate of return is concerned, it is purely based on the cash that is getting invested or withdrawn. So probably if I'm investing some X now, let's say for a 3-year period. Okay, 1 plus r cube. After at the end of 3 years, it is going to become x into 1 plus r cube. Probably let's say after 1 year, some y got invested in the project. So what we are saying is y into 1 plus r squared. Probably 6 months before 3 years, let's say after 2.5 years, when there is only 6 months more left, probably let's say some z got invested. So 1 plus r cube, 1 plus r to the power zero point 0.5, because there is only 0.5 months still left for the completion of the project. So when there are different cash flows that are getting invested into the project, and their time durations are different, what we are saying is this entire thing should be equal to the final value of the project, whatever it is. So from here, whatever the rate I am able to compute, wherein the future value, the better way to put it, the future value or the accumulated value of all cash flows, the accumulated value of all cash flows till the maturity period, equating it to the actual fund value on that accumulation date, whatever that rate of return that makes both of them equal is what is the money weighted rate of return. See, sometimes people also look at it the other way that gets defined is it is nothing but it's the IRR of the project. Either the present values of all cash, future cash flows should be equal to 0, or we are talking about the future value of all cash flows should be equal to the fund value. So in these cases, whatever is that particular rate of return that makes this happen is what is called as a money weighted rate of return, because the weightage is given more to the money. If large cash flows, are carrying more interest, we will have the money weighted rate of return generated more versus small cash flows exposed to a particular rate of return. So the large cash flow to a particular rate of return, you will see that that rate of return will be very closer to the money weighted rate of return. So the weightage is given more to the cash flows here. So that particular return where cash flows are very high, you will see that the money weighted rate of return will be more compared to the time weighted rate of return, because when we see the way time weighted rate of return gets computed, the time weighted rate of return, the weightage is given to the time of investment. So at every point in time, let's say before, in the same example earlier, okay, there was X that was invested for a 3-year period. Then after 1 year, Y got invested for a 2-year period. And after 1.5 more years, Z got invested for a 0.5-year period. So this was the only information that was sufficient for computing the money weighted rate of return. Of course, the final fund value is what I would require to find out what is that rate of return over this entire investment period. But for computing the time weighted rate of return, okay, there is a cash flow change from in this 1 year. X has been invested for the first year. I want to know before Y got added, right? This is what before Y got added, what was the total value of this X? Probably X plus some A. Means before I added Y to the list, Y to the investment, how much did X generate? Similarly, okay, now the fund value is X plus A. Then Y got added. Before I added Z to it, how much did it become? Just before Z got added, probably it must have become X plus A plus Y plus B. Then again, so which means the fund value before Z got added, means after Z got added, this is the amount of fund. What is the total fund value? So I require all these details while computing the time weighted rate of return, because I am trying to find the rate of return in each stage. The rate of return in the first stage is X plus A by X. The rate of return in the second stage, X plus A plus Y plus B by X plus A plus Y. And the return in the third stage is FV divided by X plus A plus Y plus B plus Z. So this is the fund return in the first period. Once the Y got added, this is the return that the fund could generate, and this is the return that the fund could generate. So this I equate to 1 plus I to the power T, right? Whatever the individual period returns, whatever is getting generated. So the weightage is purely based on time. During that particular period of time, whatever is the return that each investment generated, that is what we are taking as a part of the time weighted rate of return. What we have to observe here is, in the money weighted rate of return, we really did not require what the value the fund has generated in the middle. We were only bothered about the cash flows which we have invested or pulled out. Whereas in the time weighted rate of return, we require the value of the fund at each of the periods before the new amount is being invested or existing amount being pulled out. Before and after every cash flow process, we are looking at what is the value of the fund, and then taking all the returns, multiplying those returns, equating it to 1 plus I to the power t, and from here we will compute that particular I by doing this entire thing to the power 1 by t, taking the tth root of this entire multiplication or the geometric mean, weighted geometric mean of this entire multiplication to arrive at the interest rate, which is what we call as the time weighted rate of return. So the mechanism, the money weighted rate of return, probably if I can equate it to the IRR of the investments, the time weighted rate of return is more like the geometric mean, weighted geometric mean of the returns, right? So here the weightage is given based on the time of the investments, right? For whatever period of time each thing is generating a return, whereas here the weightage is given to the money, because the larger is the cash flow associated with a particular return, the chance of money weighted rate of return going closer to that particular return is a very common aspect. And generally in the investment management industry or generally in the fund management space, it is seen that the time weighted rate of return is more used compared to the money weighted rate of return. The reason being, we are not bothered too much about the cash flows. How much cash is added or not added, right? It's not bothered too much on the timing of the cash flows. It's more bothered about the return, whatever may be the cash flow. It could be 100 rupees, it could be 500 rupees, whatever may be the cash flow, how much return it is able to generate. So when I am getting a new fund, when I am getting a new investment into my project, they are all not that much in the control of the portfolio manager, because he has some X funds. How well he is able to generate a bigger return out of that X is more important, rather than, okay, when am I going to get the next Y. So that's not in the control of the portfolio manager. So what we say is, typically to measure the performance of the fund managers, it is suggested that we use the time weighted rate of return itself rather than the money weighted rate of return, because a few things, okay, both the sides you see some kind of advantages versus the disadvantages. When it comes to the money weighted, the only major advantage I see is the intermediate fund values are not required, right? How much X generated before Y got added. So I don't need the intermediate fund values, right? All I need is the cash flows, and at what point I have invested the cash flows and how much time period are they being invested for. That's the major thing I need to know. But the thing is, the once you see a large amount, a large cash flow, and associated with a higher return, you see a larger cash flow or larger proportion of the cash flow associated with a higher return, immediately you would be seeing that the money weighted rate of return will go very drastically high. but the same large amount associated with a lower return, you see that the money weighted rate of return go drastically lower. So which means it is very much sensitive to the timing and the amount of cash flows. Very important aspect. It is very much sensitive to the timing as well as the amount of cash flows. So all at any point in time we require to know that information, right? All the cash flows which are going to be invested, and the biggest problem with the IRR mechanism is there is a possibility of multiple IRRs existing, means the multiple interest rates can come up, multiple money weighted rate of returns are possible, especially if there are many cash inflows and cash outflows. Right, going with a simple mathematics, if at different points in time there are different inflows and outflows and probably multiple sign changes, like okay, first year there is an outflow, for second and third years there is an inflow, again there is an outflow for 2 years, again there is inflow for 3 years. So if I have such kind of a pattern, the more sign changes that are there, mathematically it can give rise to multiple real roots. So multiple real roots means the root of this equation is what is actually the IRR. Right. So from that dimension also what we can see is if there are multiple roots, multiple IRRs are possible, means multiple rate of returns are possible. That is one more area that it brings some kind of instability instability to the assessment. Especially it may not be the good tool when you see that the cash flows are changing signs over the entire period, not just once but multiple sign changes over the entire period. But when you look at the time weighted, okay, you don't it really doesn't matter about the timing of the cash flows, right? It is purely on how much this particular, whatever is this cash flow, how much did it generate during this period. So whatever may be the cash, it could be 100 rupees or it could be 100,000 rupees. It really doesn't matter for a time weighted rate of return, because it is purely looking at how much this 100 become 110, how much this 100,000 becomes 105,000. Probably this is treated as a 5% return, whereas this is treated as a 10% return. But when we talk about money weighted, whatever the more weightage goes towards this and the less weightage goes towards this, because the weightage is given based on the money, not on the return that is getting generated out of the existing cash flow. I hope this is making things clearer for you. So because of that reason, the only constraint probably could be you have to know the values of the fund at the end of each of the period, which means before a new cash flow is being injected, it's better that you know the fund value associated with that particular fund. So that could be one of the major drawbacks that could be associated. But otherwise, it's a very good tool to typically measure the performance of the fund managers. And in this context, there is one more tool just to discuss, which is called as the linked IRR. It's a slightly better form or an advanced form of money weighted rate of return, which is called as a linked IRR, especially when there is a difference in the timing of the cash flows, timing of the cash flows and the computation of fund value. So let's say, okay, you have invested some X now, some Y after 1 year, and Z after one more year. But let's say the fund value has been computed somewhere in the middle here and somewhere in the middle here. The fund values are not computed on these dates, but the fund values have been computed somewhere in the middle. This is the case where I can think of using the linked IRR kind of a concept. So wherein which means I am linking all the individual IRRs, right? I am linking all the individual IRRs. Probably for this, I'm simply linking X, okay, into 1 plus R1 for whatever period X may have been invested. Let's say only for 6 months. X into 1 plus R1 is equal to probably fund value 1. So X into 1 plus R1 is equal to fund value 1. So based on this, I'll compute my R1, whatever is the rate for that period. Then if I have to look out for this, right, now that I have computed the fund value here, I'm looking at this particular fund getting reinvested. So fund value 1, right, because by this time the fund value has been computed. So up to this. So fund value 1, if I am reinvesting for R2 period, and probably Y I am reinvesting at R2 for a 0.5 period. So when I am investing something like this, it is becoming equal to fund value 2. So from this I can compute what is the R2. So by this time the fund value has come to FV2. Again this is getting reinvested, FV2 probably at R3. The same way Z probably would have been invested only for let's say 4 months or 3 months. So this is giving me fund value 3. So this is from here I can compute my R3. So I have got my R1, R2, R3, which are the individual rates of return. See here, both time value and money value are getting combined, because I'm talking about different fund values for different periods and different cash flows also being invested at different points in time. So this concept will lead to different returns for the different periods, and if I really want to find out, right, if I really want to find out the overall return for this entire period, probably whatever, let's say if this is a 3-year period, I can very well write it as 1 plus R1 into 1 plus R2 into 1 plus R3, and then probably end up finding out this I. This kind of rate of return, is what we are calling as the linked internal rate of return. Obviously, now when these two are same, the timing of the cash flow as well as the day on which the fund value is determined, the timing of the cash flow as well as the day on which the fund value is determined, if both of them are equal, then I can very well say that my linked IRR is nothing but time weighted rate of return. So especially if there is a difference between the timings of the cash flow investment as well as the computation of the fund value, then we have to use this concept of linked IRR. But if we see that both of them are one and the same, then we can look at it as the time weighted rate of return itself. Now what we can actually do is we can take up a few numericals associated with the money weighted rate of return, the time weighted rate of return. In what cases the one is better compared to the other? When will one of them show a higher value compared to a lesser value? We can very well try looking out for the various aspects associated, various calculation aspects associated with money weighted versus time weighted rate of return. Once we solve a few numericals, the concept gets more and more clear, and the differentiation between these two different forms of returns becomes quite more understanding. All right. So let's take up a few numericals and then move forward on the same. Yeah. Now let's look at computing the fund value given the relationship between the money weighted rate of return and time weighted rate of return. We know the various mechanisms in which we compute the money weighted rate of return as well as time weighted rate of return. The way we compute both of them. The money weighted rate of return always goes with the cash flows added or subtracted. So if any cash flow is added, for what period it is invested, and if it is subtracted, then we adjust the remaining cash flow accordingly, and then finally compute the return. That is what we do as a part of money weighted rate of return. Whereas in case of time weighted, we are not bothered about the cash flow when it is added. Whatever is the cash that is available, what is the return that it has generated during the period before the new cash flow has been added. So just look at this caselet that is provided, and based on that, let's see if at all there is some relationship specified between time weighted rate of return and the money weighted rate of return. How do I look at what should be the fund value associated? So just to understand the question, an investment fund had a market value of 2.2 million on 31st December 2009. So 31st December 2009, I'm talking about, it is already having a fund value of 2.2 million and 4.2 million on 31st December 2012. So for these kind of numericals, it's always better to have a kind of a timeline like this. It has received a net cash flow of 1.44 million on 31st December 2011. The money weighted rate of return and the time weighted rate of return from the period 31st December 2009 to 2012 are equal. So how do I compute the money weighted rate of return in this case? 2.2 invested for 3 years and 1.44 invested for 1 year at some rate of interest R has resulted in 4.2 net at the end of 3 years. That is how we compute the money weighted rate of return equation. So probably it's as good as writing 2.2 into 1 plus R whole cube plus 1.44 into 1 plus R. This is what is resulting in 4.2. So based on this, I need to have a mechanism to estimate R, right? So probably we can use the mechanism of interpolation. Or if we are using a spreadsheet, it is even easier to go ahead with it. I'll shall show both the mechanisms. Alright, so let me use the spreadsheet. Initially we are saying 2.2, then 1.44, which is what is resulting into 4.2. So let me assume sum x. So what we are saying is we are trying to find out 2.2 into 1 plus whatever is this r, I'm saying cube, 1 plus r cube, then similarly 1.44 into 1 plus r, these two put together should be equal to 4.2, but right now the summation of these two is only 3.64. So what I can very well do is I can set this value to 4.2 by changing this value. For that, I can depend on a feature called goal seek in Excel. Right, I'll go to this goal seek, simply saying you set the target. This is the target cell. Set it to 4.2 by changing this particular cell. So it is giving me almost closer answer saying 6.59, or to round it off around 6.6%. Or I can take the help of interpolation, especially if I don't have the access to Excel spreadsheet. The better way to look at it is using a calculator, trying to find out the value of I accordingly. So basically it's like, okay, first let me start assuming a 6% interest rate. If it is 6%, then it would have become 2.22 into 1 plus 6% whole cube plus 1.44 into 1 plus 6%, resulting in 4.14, which is less than 4.2. And if I go with a 7%, what I should get is 2.22 into 1 plus 7% whole cube plus 1.44 into 1 plus 7%, resulting in 4.23. So the requirement of 4.2 lies between 4.44 and 4.14 and 4.23. So that is where I can take assume a linear interpolation to derive my R, which will work out as 6%. I'll take the input value of 6%, plus I'll find out what is the difference between our requirement and when it was 6%, divided by the two output values. This is what is the concept of linear interpolation for us, and this is what I multiply by the gap between the inputs. The gap between the inputs 7% minus 6%. So resulting in around 6.59, which was more or less similar to what we have got using the spreadsheet. So we can very well assume that in this case the R, which is the money weighted rate of return, is somewhere equal to 6.6%. If I am adjusting it to two decimals, it is working out to 6.6% as the money weighted rate of return. So this is what is the mechanism we use to compute the money weighted rate of return. But in this question, it's also said that the money weighted rate of return is equal to the time weighted rate of return. Right? So how do I look at the time weighted rate of return? Because the cash flow addition has happened on 31st December 2011. So until that time, before the cash flow was added, let's say the fund value was F. So what does that mean? The 2.2 million which was invested in 2009, it has become some F before 1.44 million was added, and that F plus 1.44 again invested to result in 4.2 at the end of 2012. So while computing the time value, we take one period to be F by 2.2, whatever is the return this has generated, and the multiplication of the different periods returns. 4.2 is the output with F plus 1.44. So basically, when we are doing this time weighted rate of return, our focus is look at all the periods where the cash flow addition or subtraction did not happen. Take that as a unit. Find out what is the final value versus the initial value. So because the cash flow got added only once during this entire 3-year period, I am considering the period before the cash flow, considering the period after the addition of the cash flow. So 2.2 might have generated in some F, and the 1.44 added to F has generated 4.2. This is over a 3-year period with a return of 6.6% per year, because we said the money weighted rate of return is equal to the time weighted rate of return here. So 1.066 whole cube is equal to this much, right? So what is this 1.066 whole cube? 1.066 whole cube, this is around 1.211. That is equal to F into F by 2.2 into 4.2 by F plus 1.44. So probably doing a simple arithmetic here. 1.211 is equal to 4.2 F divided by 2.2 F plus 2.2 into 1.44. If I find out what is 2.2 into 1.44, this is around 3.168. So probably we can do a basic simplification of the equation. 1.211 into 2.2. This I multiply it with 2.2, so 2.665 F, which works out to 2.665 F plus probably 1.211 multiplied with 3.168, which is giving me 3.838. 3.838 is equal to 4.2 F. So from here I can easily simplify. From 4.2 I subtract this 2.665. So from 4.2 I subtract this 2.665, 1.535. So 1.535 F is equal to 3.838, resulting in F equal to that 3.8. So the fund value before the addition, because the question is about find the value of the fund before the net cash flow. So which would be something like this divided by this, working out to approximately around 2.5 million. So what do I notice from here? The 2.2 million that has been invested on 31st December 2009 got translated into 2.5 million, provided a returns of around 0.3 million, resulting in 2.5 million at the end of December 2011, and another 1.44 million added during that time has resulted in the overall total of 4.2 million at the end of 2012. So in this case, if this has been the situation, then in this case the money weighted rate of return is same as the time weighted rate of return. Right, so both of them, just to summarize this numerical, it is nothing but I'm computing the money weighted rate of return by taking the various cash flows invested or pulled out at various points in time and mapping it to the final destination by taking in the compound interest associated during the period, and for computing the time weighted rate of return, I'm looking at the various points where the cash flows got added. Before the addition or subtraction of the cash flow, what was the returns? Multiplied all those sets of returns and to arrive at the overall time weighted rate of return for the entire period, which has resulted in me finding out what is the market value of the fund before the addition of the cash flow. All right. Okay. Now let's look out for a basic numerical that differentiates between a money weighted rate of return and time weighted rate of return. Right. As we have discussed earlier, money weighted rate of return is otherwise nothing but the IRR of our investment, the internal rate of return of our investment. So where we take different cash flows, I take the different cash flows that are injected into the project at different points in time, and all these cash flows I find the future values or present values, either of them. I take the future values of all these cash flows and I equate it to the final position of the project and what rate of return is contributing to this right from the beginning till the last, with the various intermediate cash flows coming in. What is the final return that is getting generated on the project? That is what is coming out through your money weighted rate of return. So all I could do here is just make a small table. First Jan, probably I'll put it in a spreadsheet. 1st Jan 2011. Then I have 31st December 2011. Then 31st December 2012 and 31st December 2013. Look at the numbers here. For this manager, initially he was given 103,080. So 103,080 is what is being given, and by 31st December the fund value has become 110,890. But at the same time he has been furnished with another 14,300. So because of that, at the end of this period, we see that the money has actually gone up to 125,000. But at the end of December 2012, he was able to generate only 125,820. He was able to generate only 125,820, and even at that point he is provided with another 14,300. So overall at that period the amount that he is having was 140,120, but by the end of 31st December 2013 that money became 120,420. So these are the various numbers that are associated with our project. Now if I want to find out the money weighted rate of return, it's straightforward. So the money weighted rate of return doesn't bother about what are the cash flows that the fund has generated intermediately. I'm more bothered about my investments or my cash flows, not the amount, not the returns what the fund has generated intermediately. So basically initially 103080 has been invested, let's say for a 3-year period, right? 103080, it has to be invested for a 3-year period, and after that 14,300 was an additional cash flow which is invested for a 2-year period, and another 14,300 was given on 1st Jan 2013 which is invested for a 1-year period. All this put together had produced 120,420. So based on this I can find out what is the interest rate during this period. Okay, let's try seeing that. So let's assume that this is the money weighted rate of return. All we are saying is 103,080 into 1 plus I cube, whatever is that I, 1 plus I cube plus 14,300 into 1 plus I square, again 14,300 into 1 plus I. The summation of all these things, so the total return or total final value should be equal to the summation of these three. This entire thing should be equal to 120,420. What is that particular value of I which makes this value equivalent to 120,420? Obviously we know that there is a loss, so probably if I start putting minus 3% or something, yes, I am coming to 121, so probably minus 4%, 118, so minus 3.3%, I am more or less there. So minus 3.3% looks like the money weighted rate of return. In this case means that particular rate of return that equates the present value or the future value, either of them. That particular rate of return that equates the present value or the future value of the cash outflows with the present value or the future value of the cash inflows. So here I am not bothered about some of the things we need to understand. I am not bothered about what was the value of the fund at 31st December 2011, 31st December 2012. I am only bothered about the final output value for the fund, and at the same time what cash inflows and outflows have come out from the fund. So wherever there is a change in the cash flow, that much is typically taken out or added back depending on whether it is added or removed from the fund, additional cash flow. So for each additional cash flow that is coming in, I will find out the present value or the future value of that cash flow and then equate it with the final result itself. That is what is the money weighted rate of return. Whereas when I talk about the time weighted, I am more looking at each of this time period. Okay, this invested, it gave me this. Then at the end of the second year, this invested, it gave me this. For third year, this invested, it gave me this. So try finding out the returns for each of the periods. So what is the first period return? The first period return is this divided by this. This is for the first year. Almost 7.57% is the return in the first year. Then for the second year, 125, 820 came with an investment of 125, 190. So 0.5% is the return. Whereas in third case, 120, 420 came out of 140, 120 investment. Because at the end of at the beginning of the third year, another 14,300 has been pumped in. So the total capital that is available is 140, 120 for the third year. So basically, while computing the time weighted rate of return, we are taking the period wise returns before any cash flow is being pumped in or withdrawn. So it is purely a measure of the performance of the fund at each of the intermediate intervals. So then I will multiply all these returns. So because this is for a 3-year period, I'll say 1 plus I cube is equal to the multiplication of these returns. So the multiplication of these returns, this multiplied by this multiplied by this. So 0.1293 and that is 1 plus I cube. So if I want 1 plus I, right, but again I want to find 1 plus I means I take this cube root of this. So this comes out to be 1 plus I, and from here if I want I can very well take it as this number minus 1, giving me minus 2.4% only. So the time weighted rate of return is greater compared to a money weighted rate of return in this case. So we'll see in what cases the money weighted rate of return will be higher compared to time weighted rate of return and vice versa, right? But just for this numerical, how to compute the money weighted rate of return versus the time weighted rate of return, we really say that there is a difference in the way they are computed, because the time weighted rate of return definitely takes the intermediate performances of the fund just before a new cash flow is invested or an existing cash flow is being pulled out of the investment. Whereas the money weighted rate of return is not bothered about the fund values at those points in time. It is only looking at our overall picture wherein you are investing different cash flows at different points in time and what is the return that is getting generated. See, all we have to see is, depending on at what point in time the cash flows are getting invested, especially when the fund is performing well. In that particular period when the fund was performing well, if the cash flows were invested heavily, then probably you see that the money weighted rate of return is much better compared to a time weighted rate of return, or otherwise it is the vice versa itself. We'll take up a very clear cut differences in terms of when the money weighted rate of return exceeds the time weighted rate of return and otherwise in the next scenario. Alright. So this is what is a typical base mechanism given a simplified data, how we compute the money weighted as well as time weighted rate of returns. Alright.